Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about residual current circuit breaker, so RCBs. So let's dive right into it. Well, first, its primary job is to protect humans. Basically, it makes sure that we don't get shocked. For example, MCB's primary job is to make sure we do not have any overcurrent event. Surge protector's primary job is to make sure we do not have any over voltage events, surges. And this puppy's job is to make sure that we don't get electrocuted. So this puppy is one of the most sensitive one. Now, this also has secondary benefits because inherently what it's doing is detecting earth leakage. Now, earth leakage can sometimes directly cause fire. Think of it this way: you have a wood. Now, wood behaves differently based on weather. Like let's say in high humidity environment, if you have a conductor, raw conductor, let's say your insulation failed and you just have normal wire, let's say a rat chewed it through, but it's now lying directly on the wood, it could set wood on fire over time because of small current. That first it will char it and then it will set it on fire, and that has happened. So this device also helps as a extra layer of protection against fire starter, because not every electrical fire starts through electrical arcing. Sometimes it happens like as a slow burn. So in that slow burn, earth leakage, if you could have detected it, you could have stopped it. This puppy does that. Now, there is one severe problem with this equipment. It has way too many names. Way too many names. It is known as RCCB, it is known as RCD, it is known as GFCI, it is also known as GFI. I have no idea. And there is also an older version of it which you should never buy. That also has an acronym almost similar to this. So it's inherently, fundamentally very difficult to grasp simply because of the naming convention. Because if I say MCB, almost anywhere on the planet people assume the same thing. This is completely a mess. So that is kind of a very bad failure of every single electrical association. They should have come up with one name. Now, what's the logic behind it? Well, logic is inherently very simple. It's just like if you have a current carrying conductor, it creates a magnetic field. That's simple. That's how transformer works. That's how almost everything that we do does work. So inherently, it's a simple thing. However, here's the interesting part. If you have live and you have neutral, basically you send electricity, you receive electricity, as in like the electron flow is reversed. Both of them will create equal and opposite field. What does that mean? That simply means, let's say you put a toroid, you put live on one side, you put neutral on one side. Let's say 10 turns, and you are utilizing a equipment, let's say 100-watt load or 500-watt load or kilowatt of load. It's going to create a magnetic field. However, because live and neutral are commonly bound to each other, magnetically speaking, they will cancel each other out. So the magnetic flux here would be zero. It does not matter how much you are drawing on the other end, it still would be zero because it's balanced. It's almost like Thanos, perfectly balanced, as all things should be. Now, what happens if it's unbalanced? That's the tricky part. The moment, let's say 100 was sent, 100 ampere was sent, and not 100 was returned, let's say 90 was returned because 10 ampere went through some let's say ground leakage or some person, then you have an unbalance. In that unbalance, this puppy toroid basically will become charged. Basically, this will be like, okay, now there will be a third coil that could detect, hey, there it's quote unquote on in on state. It should not be in on state, it always should be in off state. If current went in, current went out, it's everything same, this will be in off state. The moment there is an unbalance, it creates on. That's the interesting part. It detects based on unbalance, not how much is going there or not. Unbalance. Is there unbalance? Yes, it can detect it. If there is no unbalance, it's like, I don't care. The moment unbalance is detected, it triggers a relay and cuts the connection because it assumes that you have a fault connection. Now, there is generally also a basically bypass system that allows it to be tested. So you will have a basically resistor fine-tuned for the value that the breaker is designed for. Let's say if breaker is designed for 30 milliampere, you will have resistor fitted to that. If you have a breaker that is a bit less sensitive, that let's say 100 milliampere, the resistor would be a bit bigger to accommodate that, and then that would be directly bypassed through primary coil. Like if it was connected here, it would not have an issue. If connected outside the coil, it creates an unbalanced connection the moment you short it to neutral. So that unbalance forces the third coil to fire. I will explain why the heck it needs that test button. Now, that's the whole thing. You have a toroid, you have basically a transformer that is like completely off state. If everything is going well, it's in off state. The moment there is an unbalance between live and neutral, it fires the third coil, and third coil energizes the relay cuts the connection. That's the whole thing. All you are doing is detecting unbalanced state. Be very mindful. It does not do anything about overload, over ampere draw. That's why we still have MCB. Sometimes MCB and earth fault correction can be merged into one device, but generally they are two separate devices, and you cannot be like, hey, I have ground fault, then I'm safe from overcurrent system. No, all you are safe from is ground leakage. So that's the logic behind it. Now, how this puppy is built? Generally, on a single phase system, you will simply have a toroid, and this toroid will have three coils. Coil number 1 would be live, coil number 2 would be neutral, and these two will have same number of turn, let's say 5 turn, 5 turn, 1 turn, 1 turn. Generally there will be 1 turn only. And the third one, that is the sensing system. Sensing system would be designed in such a way that it can extract the energy that it needs to fire itself. Now depending on how much energy is needed to trigger the system, depending on how much sensitive they want to make it. Like again, if you are putting this on a distribution box, you don't want this to be as sensitive as possible. You do want some leeway because things happen. You don't want this puppy to be like keep tripping randomly overnight. So you do want it to be, let's say your plug weighs that's something that is directly on your plug, you may want that to be 30 milliampere, but something that is on your main circuit breaker, you may want this puppy to be at around 100 milliampere. So again, based on that, you will build your third coil, and that will define your sensitivity and the energy that you can directly extract from it. So third is only sole job is there to detect whether I'm on or off. The moment it turns on, it will do something. Generally it itself will fire the solenoid, because it goes through a diode rectifier, and that rectifier fires the solenoid. Sometimes it can also go through a IC, and the moment IC detects it, an IC can fire a system. It is done if you need really large amount of from some extra sensitive equipments. So generally that's the whole point. Third ring is there to do everything, and the moment you open it, it's rather simple technically speaking. The sole reason is more expensive than MCB is MCB is mass produced for a very long time. This puppy is rather, comparatively speaking, rather new. So it will take some time to come down in price, because inherently speaking this is much cheaper than MCB in terms of engineering complexity. So that's the build of it. You just have a solenoid and you have coils, that's it, nothing fancy. And again, if you have multi-phase system, you will need more coils. Obviously if you have a three-phase energy connection, you will have a different coil counts. Now, how do we deploy this? Deploying it flat out is a compulsory requirement if you have any outdoor requirements or anything near a water outlets. For example, your kitchen and your washroom. Generally, they will have GFCI. And even in India, you can easily find hotels that have like outdoor plugs. They have like ground fault detection, simply because the cable is now outside. You could connect it to something, let's say, electrically fine, but because there are people outside and there is rain, there is water sprinkler system, things of that nature, it must have a way to shut itself off safely. So ground fault detection system is very important here. Then you have a main electrical panel. Now this is becoming more and more common nowadays. It was not so, but nowadays people are realizing that people do get shocked other places than outdoors, or your bathroom and kitchen. People do get shocked everywhere. Heck, garage is a very common place, or heck, any place where you are working on electrical system, you could get shocked. So people do want to make sure that their whole house is protected. You will find devices like this. Now this generally will go next to a MCB. Be mindful, this will not work as a MCB. It does not do any damn thing about overcurrent or over short circuit system. It does not do anything. As long as it's balanced, it's like I don't care. So you could have a worst case scenario where you have live and you have neutral, and instead of shorting basically live to ground where it will trip, you are shorting between, let's say, live and neutral. This system is like I don't care. That's its one scenario where it's like I don't do anything. And even MCBs generally will not trip so early that you would be safe. So that is one fault condition that could happen. So that depends on basically appliance designer. If they designed it competently enough, even even close to competently enough, that should never happen. You should always in a fault scenario, your faulting should always go to earthing rather than to neutral. So that is done. Then you nowadays, what if you have living in an old house, or you bought a new appliance that requires GFCI because you are not very comfortable. Let's say, for example, water geysers, they have water and large amount of electricity. So what do you do then? Then you buy plugs that have generally PRCD. PRCD simply stands for portable residual current device. Now this can be bought on Amazon for very cheap prices, and they are generally rated for a lot of oomph. Basically 16 amp plugs. These puppies are 16 amp plugs running on 220 volts, a lot of power. So mind if you are in a scenario where you need something, or you are building your own workshop where you will be tinkering around with electricity, which guarantees that you're gonna get shocked, in those sort of places you can literally run all your electrical equipment directly out of this plug. So at least your probability of getting shocked for longer would be very less. Now be mindful, all these things takes time to trigger. Now generally during finalization of these devices, generally the intent is that this puppy should trigger in less than 1/30th of a second. Sometimes it could take longer, but generally that's the requirement. Is like you should disconnect the power in 1/30th of a second. Now why not faster? Because it has energy limitation. I will explain that further. So be very mindful. These things does not mean that you will never get shot. It simply means the shock, most likely in most scenario, A, it will not be very painful, B, it should not end your life. That's the hope, and that's why generally you will always hear people say at least have two layers of it. One layer in your main distribution box, and second, if you have something heavy energy intensive, please have the plug also. You never rely on one equipment itself, because A, it could fail, B, you could have a scenario where it's like, something bad has happened on the equipment end itself. So you always want multi-layer protection. It's like how your car has crumple zone to protect you, but you're still supposed to put seat belt, you're still supposed to rely on airbag also. That's the same point. You have multi-layer security. So have MCBs, have this ground fault detection. Nowadays it's coming down in price, and then have plugs if you need it. Now in India, you're supposed to get a rating for 30 milliamp. Now, why does this puppy has test button? Because this is kind of weird. We have seen MCBs everywhere. You have seen MCB. They rarely have any button to do anything to it. It's like you put them and you forget them. But why the heck this device everywhere, no matter where you go, it always has a test button? Why the heck that is? Well, reality is it's working on very low power. That third coil, that's not very powerful, and inherently it's supposed to design to trip on a very low amount of currents, because it's not supposed to give you 1 ampere of shock, and then it's like, oh, whoa, 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 I think somebody is getting, let me trip it. No, it has to work on milliamperes. For Indian examples, it has to work inside 30 milliamp. Now if you multiply 30 milliamp to 220 volt, that's not a lot of oomph. Now compare this to MCB's magnetic coil could trigger itself on a short circuit scenario where live and neutral go YOLO with each other. In those sort of scenarios, the current created could go as high as 50-60 amps to 500 and 600 amps, and that is so much energy that you put even a basic coil is like, it will destroy itself, but it will disconnect. So you do not have to worry about it. And then you have thermal system, which protects you against slow over draw of current. It's a thermal system. The metal will bend no matter what you do. It's so the thermal expansion is such a powerful force. It rips apart railway tiles. So you can understand MCBs have more than enough energy, enough oomph to break. It will disconnect. You rarely will have a scenario where it does not disconnect. This puppy on the other hand barely has anything. It's like it barely has a spring which has on a barely hold on a system that has to work on 30 milliamp hour. So power wise, it's not that powerful. So inherently it's a sensitive equipment. Now what will happen, let's say you are talking about kitchen, you have grease in the air, you have a scenario where things will get onto there, basically on the plunger side of this thing, and jam it up. And because it does not have GG amounts of power, it will detect a fault, it will trigger the system, but the plunger will simply not disconnect because it got jammed. It does not have enough energy to do its job, and now you are getting electrocuted. So fundamentally it has to have a test button. Now you're supposed to trigger this puppy every month. Every device will have test monthly, test regularly. Most of the time is generally test monthly. So you're supposed to test, have one day, on every 31st or on every first, just go everywhere, tuk, keep doing this. You have to do that because of the fragile nature of these things. Actually it's not fragile, it just does not have enough oomph. Normal wear and dust and grime can jam this puppy. You have to test this thing. Do not I put it there, at least do once a month and you will be safe. You do not want to be in a position where GFCI did not trigger because you did not test it in last 5 years. So that's why test button is so important, and that's why everywhere you will find this button. There is no way going around it unless you want to make it low sensitivity. It's it will give you 1 ampere shock. Then it's I got this. Then it will be as powerful as MCB. But right now that's the limit about this. So this was my presentation on ground fault detection systems. Hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.